All right, the next examples, I would like for you guys to, work these in small groups. Work together using the rules, practicing to see whether or not you can come up with the correct structures yourself. There's a rule at the bottom, rule number 11. Excuse me. If you're not sure, use formal charge. That is not necessary for this class. Excuse me. But if your teacher, like if you had AP chemistry or a real strong pre-AP chemistry class and you want to do check the formal charge, you're welcome to, but I'm not requiring it of this class. I just stuck it in the rules because if you go on to take another higher level chemistry class, that's information you should know. Okay, but you don't have to necessarily use it here. So what I'm going to suggest that you do is I'm going to give you a couple of hints. For example, look on the periodic table, find the group for this particular element, and see if you can do this on your own. On the next page, I want to give you a little hint about this one. And then I'm going to turn you loose to work in small groups. And when you're working in your small groups, I'm going to ask that you turn this video off so you have some time to try it before I give the answers. And then I'm going to come back and just write down the correct answers, but not work them out for you. And then if you have a problem and you can't figure it out even with the right answer and working in groups and with your teachers, you can send me an email and I can walk you through it. But when you're doing these examples, I want to point out something on this page, and that is you need to ask yourself, what type of compound is this? I gave the name. I didn't even give the structure. I gave the name. What is this? Potassium chloride. Okay, you need to recognize that this is an ionic compound. All right, and what did I just give a long story about? Ionic compounds are boring. They just form what we call salts or crystalline solids, where the positive, and this would be the formula for this, is potassium, let me see, chloride is Cl2O2, all right? The potassium carries a +1 charge. The chloride polyatomic anion carries a -1 charge, so that's the formula for that particular compound. And what you need to recognize is that the compound itself is going to be a crystalline structure. But the polyatomic anions are small little molecules that carry a charge. Okay, so you do need to figure out, using your Lewis structure rules, how is this chloride put together, what's attached to what, and what types of bonds exist, and where are the non-bonding pairs of electrons. And also when you're adding up all of the available electrons, since the chloride carries a -1 charge, you have one extra electron available to place somewhere on that molecule. Okay, so that's a little hint. So together it's going to make a crystal, but the little molecule that's the polyatomic anion is going to be stuck together in some way that you need to figure out using your Lewis structures. All right, so I want you to go ahead and work in small groups to come up with the structures of these all the way up to, let's see, all the way up to this one, H2CO. The name of this molecule is formaldehyde. You've probably heard of it before, formaldehyde. Okay, you've probably heard of it before. It's pretty stinky and it's used as a preservative and an embalming fluid. So work all the way up to there, and then I'm going to pick up with explaining how to do this one.